Hi there, welcome to my channel. My name is Christine. This video is part of the Subnetting series that I plan on putting up, which is spread across 10 short videos. This is episode 1 of the series, which is binary introduction. The topics we will cover today are 1. What is the binary and decimal number system? Second is binary to decimal conversions, and third is decimal to binary conversions. Let's move to the first point. Let's talk about the digits that are in the binary number system. Binary means two or anything that is consisting of two parts, meaning the binary number system has two digits, that is zeros and ones. Decimal number system is the one that we normally use, like zeros, ones, two, three, all the way up to 9, meaning there are a total of 10 digits in the decimal number system. In computers, everything is denoted in the form of bits and bytes. In binary, ones and zeros represent the bits, and 8 bits equal to 1 byte. And now that we know that 8 bits equal to 1 byte, the value of these 8 bits can be either zeros or ones. Now, how do we calculate the decimal equivalent? Step 1 is to first make the binary place value table. What is the binary place value table? Well, it represents the place value of bits in the binary system. Sounds confusing? Let's try to make it. Each column of the table corresponds to a power of 2, starting from the rightmost column with the value of 1, doubling with each successive column going to the left. As you can see here, on the rightmost column we have 2 raised to 0, moving forward we have 2 raised to 1, and so on till we have 2 raised to 7. Under those are the values that they possess. So 2 raised to 0 equals to 1, 2 raised to 1 equals to 2, 2 raised to 2 equals to 4, 2 raised to 3 equals to 8, and so on. Moving to step number 2, we are going to place the bits in the table. So here for example, we need to find the decimal equivalent of 1111, 1111. We first make the binary place value table, and then we place the bits one by one in the column. And here is one thing that you remember, where we are going to add the values with the bit value of 1. So this will become 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, which equals to 255. Let's take a look at another example. Suppose we want to find the decimal equivalent of 0000, 0000. First, we make the table, then we place the bits. Now, in the first example, I mentioned that we add the values with the bit value of 1. But in case of bit value 0, we do the opposite. We just don't count it. Here, the answer is nothing but simply 0. Let's take a look at some exercises. Let's try to convert 10101010 to decimal. Step 1, we make the table. Step 2, we place the bits. Step 3, we add the values with the bit value of 1. So here it will become 128 plus 32 plus 8 plus 2, which equals to 170. Hence the decimal equivalent for 10101010 is 170. Let's take a look at another one and find the decimal equivalent of 11110000. Step 1, we make the table. Step 2, we place the bits. And in step 3, we're going to add the values with the bit value of 1. So here we get 128 plus 64 plus 32 plus 16, which equals to 240. Therefore, 11110000 equals to 240 in decimal. Let's try solving one more. What would be the decimal equivalent of 00001001? So step 1, we make the table. Step 2, we place the bits. And step 3, we add the values with the bit value of 1. Then here we get 8 plus 1, which equals to 9. Hence 00001001 equals to 9 in decimal. Here are some conversions for you to try. If you try to solve them, post your answers in the comment section down below. Don't worry if you get stuck on it, we will discuss this in the next episode. Now that we tried converting binary to decimal, let's take a look at how it's done the other way around. First, let's see the steps. First one is to make the table. It's the same one that we used for binary to decimal conversion. Step 2 is to look for values in the table that are either smaller than or equal to the value that we need. It sounds confusing. Now let's try to understand with an example. Suppose I say what is 128 in binary. Step 1, we make the table. Step 2, we look for smaller or equal to values in the table. We can see that we have 128 in the table, which is equal to the number that we are looking for. Now what we are going to do is we are going to place the bit value of 1 on 128 and the rest are going to be 0. That's how we got the binary equivalent of 128. That is 10000000. And when I try to convert 10000000 to decimal, you will get 128. Let's try some exercises. Let's try to convert 192 to binary. Step 1 is we make the table. Step 2, we find the values smaller or equal to our desired number. Here we see that 128 is less than 192, so we are going to place the bit value of 1 on it. Now this is where it gets tricky. Now we move on to the next bit, that is 64. Now what we are going to do is we are going to add 64 to 128 to check if we get 192. And 128 plus 64 indeed equals to 192. Therefore, we are also going to place the bit value of 1 on 64. And then the binary equivalent we get is 11000000. And when you try to convert this decimal, you will get 192. Let's try another one, a little bit more tricky. Let's say what is 172 in binary. So step 1, we make the table. Step 2, we look for values smaller or equal to the value that we are looking for. Here 128 is less than 172. We place the bit value of 1 on 128. Then we move on to the next bit, that is 64. Now if we add 128 plus 64, we get 192, which is greater than the value we want. So here we are going to place 0 on 64. Again we move to the next bit, that is 32. We are going to check if 128 plus 32 equals to 192 or less. 128 plus 32 equals to 160, which is less than the value that we are looking for. So we are going to place the value of 1 on 32. Again we move to the next bit, that is 16. Now we are going to add 16 to 128 plus 32. Here 128 plus 32 plus 16 equals to 176, which is greater than the value we want. So we place 0 on 16. Again we are going to move on to the next bit, that is 8. Here 128 plus 32 plus 8 is 168, which is less than the value we want. Then we place the bit value of 1 on 8. Again moving on to the next bit, that is 4. Then here we have 128 plus 32 plus 8 plus 4 equals to 172, which is the value we want. Then for the last time we are going to place the bit value of 1 on 4 and the rest are remaining are going to be 0. Therefore 172 in binary is 10101100. And when you try to convert this into decimal, you will get 172. Here again are some exercises for you to try. If you do try them out, let me know by posting it in the comment section down below. We will cover the answers in the next episode, which is going to be Introduction to IP addresses. That's it for today. I hope you guys enjoyed it. If you have any questions or suggestions, feel free to comment down below. Don't forget to like and share this video and subscribe to my channel for more videos like this. And I'll see you next time. Bye.